This is the ultimate cheat sheet, kind of a thing. Okay.
Or work.
It's like the beginning of it, right? It's like, okay. So we got work and force and distance, and then we can also, by the way, have another formula here, and that is that that force can be mg. When is it mg? What are we doing when it's mg? We're lifting something, yeah. So if we are lifting something, then it's mg, and so we got to put m in there, and then we've got to say g is 9.8 newtons per kilogram. I don't know if we need to do that or not, but there it is, right? Okay. Don't need to fill that one in unless you go to a different planet, and then be careful, right? Okay. And then sometimes force is equal to mu times m times g. So it's part of the weight of the object. And when is that? When you're dragging it, yeah? Yeah? It's kind of a... So we could put a mu there, right? So these are all the things we can know. Isn't that cool? This is a list of all the things you can know. And you can approach any problem that way, right? You can write down the things you know and then use those formulas to find new things, write them down. Use those formulas to find new things, write them down. So what do we know here?
Mass.
We know the mass, 32 kilograms, right? Right, so this is, by the way, also another clue. In my problems, I'll give you the units. Isn't this always kilograms? Right, this is always newtons per kilogram, in case you wondered. This has no units. It's like, right, this one has units of meters. This is newtons. This is joules. Yeah? So you really could, robots could solve these problems, right? In the year 2000, right? Okay. So what else do we know? The distant future, the year 2000. What else do we know? The W is 1200, right? Yeah, and then what else do we know? And the mu is 0.21. Right? Now, is there a formula that we could just blindly apply? Like, could we multiply these last three things together and get the force?
Yes.
Could we write that down?
Yes.
Could we then use this formula with work and force and find distance? Holy cow. Yeah. So go do that. 2 steps. It's a 2-stepper. Step one. Find the force of friction. Step 2. Find the distance. Yeah? About distant future. You guys know what I'm talking about? Robot solo. Concords. Yeah, you have to. I don't know if, is that appropriate? It kind of is. We'll put it on our agenda here. There we go.
Wait, if you spell it backwards, it says...
You might as well get out a whiteboard. Put your answer on the whiteboard. Yeah.
That's cool.
Should be in meters. Should end up in... Does it say newtons? That's kind of funny.
How did I...
This is a brand new whiteboard problem, so, you know. Yeah. Do you see what's cool about it?
Yeah, it's backwards.
Yes, that's right, that's right. My units on the PowerPoint are wrong. That's right. Yes.
Wait a second.
You solve them for D, that's right. We could write down what these are too, couldn't we? This is work. This is force. This is distance. Mass. No, I think you're going to, yeah, I think you find F first. Yes. Yeah. Yeah. Only it's meters because it's a length. That's right. My units are wrong. Yeah. Read it backwards. That's right. My kids wrote that down. I'm like, what? What? That's right.
Hold on 1 second.
Read it backwards. Oozy rat in a sanitary zoo. That's right. I get 1/10 of that. I don't know.
182.215.
I get 18.2. I don't get that number.
What?
Is that I get 18.2.
I don't think so.
18.2. The distant future.
Wasn't pressing official sentences. They make any sense.
I know, yeah.
Not like race car.
You got to add like spaces and things like that.
I even got it.
Try go hang a salami. I'm a lasagna hog.
Oh, I just.
Write that one down. Go hang a salami. I'm a lasagna hog.
You don't know how to do that.
You trust me? Don't trust me. Never trust me. I'm a flower baby stabber. Do you guys hear? I gotta turn off the sound. Sound's back on. Sound is back on. Woo! All right. Are you guys ready for the next one?
Yes.
All right. To be or not to be does 137 joules of work. Where does that go? Where does that go?
No. In the
Is work, right? What else do we know?
back.
5.25 kilograms. Okay. Now, what are we doing? Dragging or lifting? We are lifting. Yes, so we want to use this. We can find force, then I believe we can find distance, right? Height would be the distance. Acceleration. You don't have to on this one.
And then you just do.
You're going to do this. You're going to do, right? Do that guy first. Fill it in. Then you can do this and find D, right? Yeah, that's what I got. Yeah.
This stuff
Yep.
isn't going to be on the final, is it?
Yep. No. It's too bad that it's not, too. Yes, we decided on the final, Mr. Duggan and I. We're going to give you a projectile motion problem and a force problem. Yeah. You're going to work on it for some period of time without any help, like it's a test. Then you're going to get, like, you're going to work on Quizlets together that you do and turn in that are very similar to the test questions you just taken. You can also talk to people about the test. Then you'll get your tests back for some period of time afterwards. That's right. And be able to revise it. Don't you think that's kind of an interesting thing to try? It's experimental.
I don't know. I don't understand this problem.
Yes. Is there a decimal point there? I love that. That's great. I need glasses. I'm like, yeah. Yes.